Hello everyone, I am Amit Nehra, third year engineering fields, and I'll be talking about gas sensors. This is going to be the flow of our presentation. And coming to the introduction of gas sensors, it basically detects the various gases present in the vicinity of itself. It interacts with the gas to measure its concentration. Coming to the working principle of gas sensors, well, there is no general working principle because for different gases, we use different sensors for better sensing. And the most commonly used are electrochemical, which are based on electrochemical sensing technology because of the low cost. It works on the principle that each gas has its own breakdown voltage, and based on the breakdown voltage, sensor identifies the gas, and the discharge current, the amount of discharge current determines the concentration of gas in the air. Now coming to the types of gas sensors, and this classification is done on the basis of sensing technology. First one are metal oxides based. In this, change in resistance is measured of a thin film due to the absorption of gas molecules on the semiconductor. The resistance changes, and in case of capacitive, the dielectric constant between two plates of the capacitor changes uh, due to the presence of gas between the plates, and that's how we sense the gases by measuring the change in dielectric constant. In acoustic wave based, in this a piezoelectric material is used, and the resonant frequency determines which gas it is. Of course, in this calibration part is more rigorous. It requires much work. In case of calorimetric, change in temperature is measured because of the burning of combustible gases at catalytic surfaces. The change in temperature is measured, and the change determines the concentration of gas. In case of optical, uh, phenomenon of spectroscopy like luminescence, phosphorescence, fluorescence determines which gas is present in the air, and the intensity of this phenomenon determines the concentration of gas. In case of electrochemical, as explained earlier, electrodes present in sensor react or might help in the reaction with gas, and the current produced helps in determining the concentration of gas. The reducible gases are accumulated at cathode, while the oxidizable gases are accumulated at anode. Oxidizable gases like carbon monoxide and hydrogen sulfide both are poisonous. Now coming to the circuit diagram of carbon monoxide gas detector. So this is an electrochemical based gas detector. Here you can see cathode, here anode. On anode it will accumulate because it is a oxidizable gas, and at cathode the reducible gas accumulates. So carbon monoxide will accumulate here, and after accumulation at anode, this carbon monoxide will go through the following reaction. This H2O is generated during the combustion of hydrocarbon, which was the cause of this CO, carbon monoxide. So as we can see, this reaction leads to the production of 2 protons and 4 electrons. They are charge carriers. So this reaction is the root cause of flow of current, and the amount of current is measured, and that's how we know the concentration of gas in air. Now coming to the applications of gas sensors in industry, it is used to detect and monitor toxic gases like carbon monoxide, methane, hydrogen sulfide, and this is done for the safety of workers. In environmental monitoring, it is to monitor the air quality index in a particular zone. In automotive industry, to monitor the exhaust emissions in vehicle. In healthcare, to monitor patient health, especially when undergoing respiratory therapy or anesthesia. In agriculture and food, to monitor gas concentration while packaging and storage of food products. consumer in as it's directly sold as consumer products, fire detection alarms, aerospace industry for gas levels in cabin. Now coming to the limitations of gas sensor. First is sensitivity to other gases. I mean, our sensor can detect multiple gases if it is sensitive to many gases, not just the gas we are interested in. So this will give the increased concentration. This will not give the accurate results. In calibration, there is a need of periodical calibration to ensure accuracy of the sensor. Operating conditions like temperature, pressure, humidity, they interfere with accuracy, sensitivity, and selectivity. Some sensors are expensive, and some sensors have more response time, so they might not give real-time feedback. And specificity of these sensors. This means that a particular gas, a particular design, a single design is not enough to detect and sense gases. For different gases, we need different designs. Now, discussing the ongoing innovative applications of gas sensors. Now, talking about within the sensor by improving its sensitivity and selectivity. We are using nanomaterials. By manipulating the structure and composition, they can enhance the sensing properties like sensitivity, selectivity, etc. And by using machine learning algorithms, by identifying patterns and analyzing sensor data, they can adapt to changing environmental conditions and can give us more accurate results. And wearable sensors. And there is a growing demand in developing these sensors so that the user can get real-time feedback and avoid the exposure to harmful gases. Wireless. It is basically becoming more common for difficult to reach locations, I mean remote areas, and they are used to monitor large area. धन्यवाद.